Okay, so for this video, we are going to look at different triangles and try to determine whether or not the triangles are congruent to each other. And we're going to do that by looking at the information that's given to us and trying to figure out which postulate would match to help us prove that these two triangles are congruent to one another. So what we're going to do on this picture that I have right now is let's talk about the two sides, or the side that is shared between both of these triangles. So I'm referring to this side, line segment BC, which is going to be congruent to line segment CB. And I know that because it is the same side. It's the same side that's being shared between the two triangles that we're looking at. And that is called the reflexive property. Okay. So then the next statement that I want to recognize here is the measure of these angles. So angle, let me write this out. Angle DCB is going to be congruent to angle ABC. And the reason I know that those two angles are congruent to each other is because they are alternate interior angles. So let me write that out. Okay, so now when I'm looking at my triangle and I'm trying to determine, or my two triangles, and I'm trying to determine what postulate to use to describe that they are congruent to one another, what I would do is I would look at starting at angle C. Oh, I'm sorry, starting at like vertex D. If I go to the left, I'm going to cross over a side, and then over here at C, I'm crossing over a angle. And then when I'm going up to B, I'm crossing over a side. So to write that out, we would have side, angle, side. And so that's the postulate that I would use here to prove that these two triangles are congruent to each other. So my last step would be to say that triangle ABC is congruent to triangle DCB. And I want to make sure that the order that I'm putting those letters in is corresponding correctly. So for example, I know that the angle A should correspond with angle D, and angle B should correspond with angle C, and then angle C should correspond with angle B on the other triangle. So we want to make sure that we're putting that order in correctly. And then the reason why these two triangles are congruent to each other is because of the side angle side postulate. Let's look at another example. So here I have two triangles, and let's look at the information that is given to me. I know that line segment AB is congruent to line segment DB. That information is given. And then I also know that C is the midpoint of line segment AD. What it means to be as a midpoint, it means that I'm cutting this line in half. So I'm cutting it into two equal parts. So that lets me know that line segment AC is going to be congruent to line segment DC because they're going to be cut in half. They're equal in size. So the other thing that I can get from this picture is that the two triangles are sharing a side. So side BC is going to be congruent to side BC. And the reason is because of the reflexive property. Because it's the same as itself. So BC has to be itself on both of the triangles since it's sharing that side. So let me go ahead and just add these 3 tick marks right here so we can see a visual picture. Now what I would do is I would say, okay, I have enough information to prove that these 2 triangles are congruent to each other. So I'm going to put like my finger, my pen, my pencil on point A, and I'm going to move across to C, and I know that I'm passing over a side. And then when I go up to B, I'm passing over another side. And then when I go back to A, I'm passing over a side again. So that lets me know, because those tick marks are corresponding to the same lengths on the other triangle, that I'm using the SSS or side, side, side postulate to prove that triangle ABC is congruent to triangle DBC because of the side, side, side postulate. All right, let's look at, and guys, I want to also point something out or draw your attention to something here. And this is just a little bit of extra information. Let's say that you found a different way to solve this same picture where we're looking at these 2 triangles and we're proving if they're congruent or not. I want you to consider the fact that we have a larger triangle. If we get rid of that line in the middle and we look at the larger triangle ABD, I know that these 2 sides are congruent because that's given information. If that's the case, that means that this is a isosceles triangle. So this angle has to be congruent to this angle over here because they're going to be corresponding to sides that are also congruent to each other. So the side opposite from angle D is equal to the side that is opposite from angle A. So I know that these angles are also going to be congruent to each other. So another way that you could prove that these 2 triangles are congruent is by the side, angle, side postulate. That's just something to consider. There's multiple ways to prove that triangles are congruent to each other. Let's look at another example. So here I want to see if these 2 triangles are congruent to each other. So let me start looking at the information that I have. When I'm looking at the triangle at the top, I notice that we have the 55, the 35, and I'm looking at the triangle at the bottom, and it also has 55 and 35. So I see some congruent angles. And then I also see that both triangles have the side that is 7 centimeters long. So let me do a little bit more work to figure out more information on the pictures that I'm looking at. Because at the bottom, if I'm looking at the bottom, I see here I have, and I'm going to delete this after I write this, so it's not going to be too much in the way. So here I have an angle, and then I have a side, and then I have an angle. Whereas compared to the other triangle above, I have an angle, and then over here I have an angle, and then I have that side 7 that matches up with the one at the bottom. So I'm going to erase what I just did in yellow, but that, just by noticing that when I'm looking at this picture, it's making me think maybe there's more to it, and so I'm going to do a little bit more research into figuring out what type of triangles I'm looking at. So I would be thinking to myself, well, what is this other angle over here? So I know that the sum of the interior angles in a triangle have to add up to 180 degrees. So I'm going to subtract the two angles that I do have. So when I subtract those two angles, I'm actually going to get 90. That is telling me that my mystery angle over here is actually 90 degrees. And because the triangle at the bottom also has those same numbers of 55 degrees and 35 degrees, it's also a 90-degree angle. Now, if you remember, if I'm looking at a right triangle, I have sides A, B, and C, where C is the hypotenuse because it's opposite from the 90-degree angle. Well, I'm noticing that at the bottom triangle, C is 7, which is the longest side. But on the triangle above that, C isn't given information. So what that means is that that side opposite from the 90-degree angle is actually has to be bigger than 7 centimeters. So there's no way for these two triangles to be congruent to each other, because the hypotenuse always has to be opposite from the right angle, and the hypotenuse has to be the longest side. So it doesn't make sense here that these two triangles would be congruent to each other. So I hope that was a helpful video to kind of review some of the concepts we've been covering during class.